Hey students, we're going to continue our discussion of end-of-arm tooling, and now we're going to watch a bunch of different videos and pictures and try to evaluate what was done in the design of these end-of-arm tooling designs. So let's get right to it. Okay, so this is a sheet metal end-of-arm tooling, and so let's go ahead and watch it and see what we learn. Right, so it goes over and it picks up a piece of sheet metal. It's using suction cups to do it. It drops it off on this stand, and by letting it go, it shakes down into the corner to position it accurately. The robot now places it into the brake to bend it. And you can see that it follows around as the sheet metal bends. It has to reposition to grab it so it can put the other side in. Had to do a little bit of repositioning because of the cables. That's one of the reasons that you want to minimize the amount of utilities that are needed on the end of your part. You can see that after each bend it is often re-gripping. And the reason that it regrips right then before the system is let go is it's using this as a datum for regripping. Now there is a limit to how good it can do with that. You can see there the suction cups that are on this part and the two hoses that are providing suction. This one does not appear to have any mechanism to know out on the gripper that it has achieved suction and that it's holding apart. What you would do on this kind of gripper is back here at the base of the robot, you would have a pressure switch, and each time you tell it to grip, you would check to make sure that the pressure switch was made, meaning that it had in fact grabbed the part. That's not a very smart way. By that I mean there isn't much intelligence in the system for that. It's just kind of binary. Yeah, it grabbed it, or no, it didn't grab it. You'll notice that there's a fixture over here on the side to drop the part off so that the robot can flip it around the other direction, and then it puts it into storage. Okay, so what do we think about that robot? Determinism? What do you think about the determinism that we saw in that robot? Really almost no determinism at all, right? All of the positioning is provided by external fixtures and features. After the first time that it picks it up out of the corner tray, which is giving it the position, every other time it is picking it up reference to how the last bend was made. But if the first bend is made incorrectly, then those are going to get further and further off as you go along the process. And so it's easy, there's sort of a cascading effect on the positioning that could make the errors grow and grow. All right, let's get rid of me and look at the next sheet metal bending cell. I'm actually going to turn that down a fair amount just so we can talk around it. So this brought a piece of material out and took an image of it to figure out how to set it down. And so that's fine. It just takes extra processing power to do it, but it means that you don't have to be careful in how you store the parts. The first robot can pick up any part and then put it in the right orientation for the second robot to pick it up. So as we look at how this robot works, it's actually a fairly simple gripper. So a couple of things about this gripper that are really good. One is, look how small that gripper is. It allows it to get really close in here, because you see each time the bend gets closer and closer in, the robot is going up by the fingers and getting closer to the system so that you would be limited by the size. I like the way that the robot does such a good job of throwing the part. Now this is one of the neatest things about this robot. The same gripper that grabbed the part by squeezing it can do an inverse squeeze, sort of an expansion of the two fingers, and using little tabs that are on the outside, it can grab the parts of the brake, and it can go get different different mandrels and such for the brake. So that's a really neat part of this system. And in fact, it also has over on the storage system a way that it can measure each part and know that it has the correct part. Okay, so what do we see on that robot? Well, it's a really simple gripper. It's a very robust gripper, you know, a big metal squeezer. It has multiple functions in being able to do something when it closes and also something when it opens up. So both of those are really good actions. We noted that the gripper was really small, which allowed it to get very close to the process that it was working on. It again does not have any determinism though, does it? It's just grabbing the part in one place, and it has no idea where it's grabbing the part. It is, we are depending on it having grabbed the part correctly at the very first station when the first robot placed the part in the correct orientation. And so if the robot comes in and bumps the part on the way in and grabs it in the wrong location, then the part will be scrapped after that. So that is a downside of these. Let's keep going. Okay, ooh, stop. Yeah, let's talk about a machining robot for a minute here. And so what this robot is doing is it's going in and picking up these disc-like pieces, and you can see the way that it's grabbing it looks like a three-jaw chuck from a lathe, and these are parts that are coming in and out of lathes. So you can see it can hold a part over here as well, has fingers that slide radially outward, and they can also slide radially inward and grab the part. We don't have a way to tell if it knows that it's grabbing the part, but I'm almost certain that this fixture would. Gently set the part down. Okay, so it goes and grabs a piece of stock off the incoming stock tray. And the neat thing about having two stations on this gripper is that when it goes into the lathe, it can grab the part that's coming out of the lathe and then put this incoming stock into the lathe. And because it doesn't have to hold more than one of any type of part at a time, it can switch which gripper it's using. So now it's going to go in and drop it off in the stand. Notice the V block positions it accurately. It flips over and picks the part up, and I think right there was a little proximity switch to tell where it was. Let's go back and look at that. In the stand, let's go right there in the stand. See this bar coming out? Now that is looking at a location on the part, and that is going to tell it that it has a part in the gripper, which is pretty important to note. All right, one last thing that I would say about this is look at this part. So yeah, it's a steel part. It's about 6 inches in diameter. It probably weighs a few pounds. Look at the size of this robot. This robot has a huge capacity, and the reason that it has such a massive capacity is to give it enough stiffness to accurately locate the parts and to carry this end effector, which is on here, which can carry 2 parts. So this is a pretty expensive robot because of the size. And so, you know, even this end effector is not terribly large, but it could be made lighter. It doesn't have any lightning holes in it. It could certainly be reduced. Notice that it sprayed off the part with air before it grabbed it just then, so that allows it to not grab on chips because there wasn't any cleaning off of chips that was done before. One other problem with a robot this big is robots this big have enough force capability that they will kill you. And so a cell like this, you absolutely must not ever have a person inside a cell like this, because if the person gets between the robot and the machine, the robot is strong enough that it will just crush the person against the machine, or if it comes around and smacks them in the side of the head, it will just kill them. So a system like this, you would have to have safety fences all around. You would have proximity switches on the gate so that the gates had to be closed for it to run. You would generally have a light curtain just inside that, so even if it was closed, if somebody broke the light curtain because they were inside the fence, and that would stop it from working. So anyway, there is some of the reason that now people are using cobots, which are collaborative robots where you can work around them. They have a lot more sensors on them so that you can be near them, and they operate more slowly and have a reduced load. Okay, a couple final things for this. We noticed that the part could grab in 2 locations, and it probably had a proximity switch sensor on it. Look at the size of the umbilical that is going out to that end effector. And I don't know what all of these are, but if any of those are cables, it's probably 10 or 15 extra pounds of cables that are strapped to the side of this robot that count against your weight capacity. And so that's one of the reasons that you want to be really careful with making the simplest method of grabbing and releasing that is possible. In this case, they probably thought that it was worthwhile because of their need to grab and release really precisely. And so they took the weight penalty, meant that they had to buy a bigger robot, means that a person cannot be in the cell except when you're setting it up and operating at a very slow motion. Okay, so this is a company called Robotique, and this Robotique gripper is going in and it's grabbing parts that are much like the parts that we just saw. But remember, in the last one, it was grabbing in 3 directions, so it would self-center the part and it would have it in exactly the right location. Interestingly, this is a standard gripper. You just buy these grippers, and you can see that it's kind of one of those designs that we saw in the previous video when we were looking at ways to make things close. This one has parallel motion of the 2 grippers that are hanging down, and let's watch it. So it goes in and it grabs the part, goes into the mill, sets the part down, lets go, and comes back out. After it's machined, it goes in and grabs the part and comes back out and sets the part down. So one thing about this that is that this has a camera right here. So this little puck in the middle and the light is a camera, so that as it comes in, it will identify that in fact there is a part where it needs to be, and that allows it to know that it should pick the part up. It might be able to do some understanding of the orientation of the part if it needed to, but in these parts might not. They're nearly symmetric, so it would be pretty hard to do that. Okay, so using a standardized gripper saves money. You don't have to build another gripper, but this one doesn't do any locating of the part. It just is looking at it and then grabbing it in the right place, and so the machine then has to have a better method of grabbing the part. One thing you'll notice about this is working on a vertical machine. You see all the chips on the part. Those chips would also be around the fixture, and so there must be a way to wash the fixture off in between parts that's happening in the background. Okay, so let's look. This is another vacuum part, end effector. You can see that this one has been lightweighted a lot, so it's sort of minimum size parts all the way around it. So let's look at this really quickly. What do you think of this? So this is also by Robotique, or Robotic, I don't know, and this is magnetic. So you just have to supply electricity to it, and it energizes these 4, and it will go around and pick up the part. So what do you think about determinism? Would there be good determinism with this? Probably not. All it's doing is sucking the part up against it, and so there has to be something else that positions the part correctly on the end effector for it to work very well. Minimizing power sources, yes. Using lightweight power sources, no. So magnetic is a really heavy way to do this, even if they are electromagnets, which they would be here because you need to turn them on and off. They have to have a lot of copper coils to create those electromagnets. So it's very heavy and it takes away from a fair amount of your robot's capacity. That being said, these are cobots. They are robots that can work around a person, which is really nice because then you don't have all that safety equipment. It does mean that the robot is more expensive, slower, and less strong, but the person can work around it or work with it. What about this one? So this is another robotic system. This is lifting really big, heavy steel parts, and so this one is on a massive robot, but partially because it's lifting these huge parts to go in a lathe. Again, magnetic. Well, one thing that we see about this is it's a little bit more deterministic. See, it has an arch in here, and so it is doing some side-to-side positioning of the part, though lengthwise it's not doing any more than that. But the umbilical going down to the end effector is quite small, and so that is a good thing. How about this one? This is a finger palletizer, and so you can see there's a rotary joint right up here and one on this side as well, and those fingers rotate out to the sides, and it comes around this pallet of stuff and then comes and fits underneath it. Well, one thing it does is it supports the part really well. It's not deterministic, but these parts have to be supported all the way along the part because they're like bags of concrete or some material like that. So you have to support it all the way along. It also does some positioning side to side. Once it grabs it, you can see there are little pusher bars in here. So as it closes it, it positions it side to side. It's not positioning it end to end. This thing is enormous. Now, the stack of these that they make is about 8 feet tall, so it has to be a pretty big robot anyway. But look at the size of this end effector. Look at the complexity of the end effector of all of these drives up here. And it looks like there's compressed air on the back as well with some pistons. So this is a very complicated end effector, which again requires a bigger robot, but it may be the most simple solution that really works well for this. A couple final ones. This one takes these boxes and positions them at the right distance along the width of this conveyor belt so that they go onto the pallet at the right location. This C-frame clamp is sort of like the magnetic one that we saw before, except that this one is using a piston to close up on the part. You can see that it has a different kind of clamp down here on the other end, I believe, for grabbing the part differently. Pretty big, pretty heavy, but it's a really heavy part to start with. Taking the 2 gripper design and making a 3 gripper design. This was from a paper on how to pick apples robotically, and kind of an interesting method of trying to identify where the apple is, close up on the apple, not hitting the stem, touch it in a lot of locations to reduce the load in any one point on the apple so that you don't bruise it. So interesting ways that they're doing that. And so this is further along that palletizer that we saw before, where it was positioning the boxes. All the boxes slide into the top of the part, and you can see there's a little separation down here. The big fingers go down, scoop underneath. These end gates right here swing down from the sides into place and press the boxes in on all the sides. And then, so I think we'll be able to see that. Oops, at the end of the video. Okay. So here is starting with the boxes. You can see the boxes are sliding down. It rotates them and positions them, and it only has to do it loosely because after it has positioned them loosely, they'll go into the machine, has a finger system that comes down underneath, supports them underneath, and then the grates swing in on the sides to compact it together a little bit. And then the system goes until it's done an entire pallet's worth. It's also instructive Okay, so that's how they set them down. There is also the bag palletizer, which is pretty neat to see just because it's lifting 50-pound bags of mulch into place. Okay, so that is some of the way that some different design practices. If we were to evaluate those, it would be good to think about, how complex is this? Is everything there necessary? How does it do the job really well? One of the things is that one of the key characteristics of this is that the end effector is doing all the positioning because there is not a fixture at the end. It is picking them up and it's just dumping them onto a pallet. And so the end effector is doing a lot of that work, which is pretty neat that it's able to do it. Okay, in class we're going to do some design of end of arm tooling and see how we can do with it. Look forward to seeing you there.